My name is Kevin Peers with EXFO, and today I'll be covering testing CPRI over fiber using EXFO's iORF application. So I'm going to go and jump right in. So basically we'll be covering, I'll talk a little bit about PIM and interference. I'll talk about the different test solutions that we're using today to do that. So all the different bits and pieces of the FTB-5G kit, the 88260 module, those types of things. And then we'll get into the actual test setup and report generation there at the very end. And so that's kind of from a higher level what we're going to be covering. So as far as PIM and interference, as many of you know, this is a huge issue that we run into within the wireless world here in the front haul. So obviously, mobile networks, as we start increasing capacity, we're starting to see a lot more issues with interference, whether from RF interference or from, passive intermodulation, those types of things. And so these are really big headaches for providers today. And so what are the two main types of contributors for PIM and interference? Internal PIM and external PIM, right? So those are the two things that we'll be evaluating and looking at with the tester. And of course, when it comes to RF interference, there's different types of RF interference, like same carrier interference, things like adjacent interference or co-channel interference and stuff like that. In-band interference, like harmonics, intermodulation, those types of things. And of course, something that we run into quite a bit, impulse noise, due to external sources. We've been running into this in the RF world for quite a long time. Your light dimmers and, bad leaky Wi-Fi from a remote camera or something like this. There's a lot of different things out there that can cause impulse noise and external source interference. And so these are some of the things that we'll be looking for, right? So there are a lot of challenges within the world that you're dealing with, obviously. And this is just a cool image that I got off the internet somewhere. So I thought you'd enjoy that. But basically, the reason why we do this is really to improve the performance of our network, keep our customers happy. So we want to identify the common sources, things like internal PIM, the most impactful stuff, like, for some reason, a jammer or, overshooting, those types of things. And of course, the more unpredictable stuff that we see in external PIM quite a bit. And so these are some of the things that are why that we're doing this, right? And as far as the test solution goes, we will be in this demonstration using our FTB-5G Pro kit, more specifically the module that's inserted in here. This particular one does quite a bit more than just the iORF stuff as iOptics. So, it'll do 5G spectrum, FR1, FR2 stuff. So there's a ton of things that the FTB-5G Pro kit will do, but it is the intelligent optical RF stuff that we're really going to focus on here today. And so essentially, this is going to require using in this example, the FTB-88260. We have other modules that do support iORF as well, but in this particular example, this is what I'm going to be using. Along with a splitter and some fiber inspection and things like that as well. So, right? And so we're going to have some sort of an optical tap. So we have our own optical tap here, so that's what I will be using. And so this particular one has an 80-20 split. So 20% of the power is pulled off into the monitor port, where we can actually look at the RF spectrum. And of course, you're going to want, so we're going to have the test set, the FTB-1 Pro, the module that's in it. We're going to have our optical splitter, a simplex fiber and a duplex fiber, as well as some way to inspect and clean connectors, connectors, which is incredibly important. And obviously, you'll need a network to test it on, right? So these are kind of the tools that I'll be using here today, and I'll demonstrate that. So just to jump straight into the setup. So the setup of the device, right? And so from a very high level, one of the first things we want to do is, lock out my sector or carrier first, right? So we want to lock out the sector or carrier so we don't start dropping calls. And then we need to insert our optical tap. And so you'll see here on the right, I kind of have a diagram of how the optical tap looks. So that's the first thing we want to do is lock down our sectors and carriers, and then insert our optical tap between the baseband unit and the remote, right? So we're going to be between there. We're going to run the signal through the optical tap and back out, and then we'll split off a portion of that signal for us to look at, right? And so that's basically what you want to do first, right? And so from that very high level, if we look at these devices again in place, this is what we're going to focus on right now. and so is plugging into the actual module itself. It is very important to mention that your transceiver that you're testing out of needs to be in A1. So it needs to be in the A1 port here, right here. And so you'll see where it says A over here, and then A1. So we need to be in A1. That's very important to understand. And then if you look at the tap itself here, you'll see that there is, essentially a single mode side and a multi-mode side. So we can support multi-mode fiber as well. And so we have the two different sides here. In this example, I'm using single mode fiber, so I'll concentrate more on the left side here. And what we're looking at is there's 3 different ports. So the first thing you want to do is you want to disconnect from the baseband unit where your radio comes in. So the fiber coming in from your radio into the baseband unit, we need to unplug that fiber, inspect it and clean it, and then plug it into the A section of the tap. And then now you have a vacant port on the base station. What you do is you take the duplex jumper that we talked about earlier, take that duplex jumper, plug from that vacant transceiver inside the baseband unit that was going to the radio. So the fiber coming in from the radio, that port on the baseband unit, you will plug into the B side here on the optical tap. And then you'll take that simplex jumper and then you'll plug from the A side here, if you want to monitor the A side, over to the receive port on the transceiver, right? Over to the receive port on the transceiver. And so whether it's this one here, whoops, or the one above it, right? And so if you're using the 88260, which is what I have up here, then you would plug into the receive side on A1. If you're using something like the 8880, then it'll be the receive side on port 1, right? So either A1 or port 1, so depending on the device that you're using. And so this is basically how it looks. And if, and let me show it to you on a drop down here, because I think it's very important for you to see this and understand it. So I'm going to go ahead and transition here to my actual platform. So this right here is the FTB-1 platform itself. And then on the top here, I have my 88260, right? So this will test up to 100 gig. And over here on A1, I have a transceiver. Now, of course, I'm in my office, so I'm not plugged into a radio. So I just have a loop back plug on there. But essentially, I want to make sure and take my simplex jumper and inspect and clean it, per your practice. And so in this case here, just for the sake of time, I'm just going to do a quick little cleaning with my cleat top here. And I'm going to go ahead and plug that into the receive side here of A1, right? Then I'm going to take the other end here, and I'll do a quick cleaning here as well. Let me do that. And I'm going to take my optical tap here, and then you'll see it's the same one we have up on the presentation. I'm going to go ahead and remove the A side plug here, inspect and clean this, of course, and then plug it in. It's always good to get a measurement of your power before you start to see what your power levels look like, your optical power levels look like before you started testing and then after. So I went ahead and plugged that in, and then I'll go ahead and just open up these other ports here as well, just so you have an idea. And so essentially what we'll do here is that we'll unplug the fiber that's coming from your radio into your baseband unit. So we'll go to the baseband unit, we'll unplug the fiber that plugs into that your radio plugs into, and then we will move that over to the A side over here. We'll move it over to the A side. So now I have the fiber coming in from the radio into here. Then I will take another jumper. So, I'll take the duplex jumper that I had, and of course, clean and inspect that as well, as we talked about, and then plug that in from one side here. So you'll take the duplex jumper here and plug it into here. So on the B side here, if I get it lined up here. So plug it into the B side here, and then the other end of this jumper, I would plug into the vacant transceiver where I just pull the fiber that's going over here, right? So the transceiver that the radio feeds. And so I'll plug that into that. So essentially what we're doing is we're coming in from the radio, and then 80% of the power is being pushed over through here. So it's passed through. So 80% of the power is passed through, and this takes the signal from the radio and takes it to the baseband unit. and then the other side brings it in from the baseband unit. So basically we just have a loop here, and 20% of the power is tapped off to here. So if you want to read the A side, then you'll plug into this port. If you want to read the B side, you plug into this port. So that's essentially what you do there. And so now that we have all that plugged in, then we can get to the actual testing itself. And so let me switch back over to that camera. Here you go. And so essentially that's what we have here. So now if we go to the next step here, we can kind of, look at that. So basically what first thing we want to do is we want to start the iORF application, right? And then we get into the setup. And so within the test set itself, so I'm going to go ahead and switch. I actually have the test set here logged in remotely. So I'm going to go ahead and show the test set. Let's see, let me pull it up here. Give me a second. There it is. And so I'm already starting iORF already. But essentially how you start iORF is from this main toolbox screen here, which I'll switch back to. So main toolbox screen right here. You'll see the iORF icon. So we'll launch the iORF icon, and then that will launch iORF. So this is iORF right here, and I can move my head out of the way a little bit here. Let's go to the bottom left here. And so I'll move my head out of the way just so you can see a little bit better. But essentially, this is the main setup. So as you notice right now, we have link down because I don't have any radio plugged into this, right? I don't have a network plugged into this at all. But this is normally what it would look like. As soon as you have the tap all plugged in and connected, then you should start seeing the status change here, right? You'll see the link going up, and then the rate will be negotiated. So you'll see a little bit of interaction and words being exchanged here. Once it starts up, essentially this is what iORF looks like when it's ready. So up here in the top right, it says ready. We see that right now we have receive power coming in. So neg 6.5 dBm. That's an important number to remember. And then, some of the transceiver information you have in here, right? And so right now we auto-detected for rate 7. So we auto-detected a rate 7 here. The only thing that you really need to do, well, the primary thing that you need to do is go into center frequency here and just input your center frequency. So in this case, I'll put 700 megahertz. And then I can apply this to all my containers. So in this one, when it's scanned, it saw 15 containers is what it saw, right? So it saw 15 containers. If there's different bandwidths, then you can uncheck, say if one is 10 and one is 20, you can uncheck it, just check all the same bandwidths together and scan those separately. So that'd be a common thing. Within advanced here, there's only a few options here. Your detector sensitivity for peaks and your PIM threshold, right? And so quite honestly, all you really need to do once you have all of this set, center frequency, containers you want to scan, just go and hit start. And basically iORF is going to go in there and scan each one of the containers and then give you immediate feedback. So as you see over here on the left, you see where it starts to populate. And so we're going to go in there and populate all, I think, 15 or 16 containers, whatever it is. And you can see the progress as it's going. Right, you can see the progress as it's going, and you can see how fast it is. I mean, we're already halfway there. It took about 19 seconds here, right? So we'll go ahead and, let that finish up. And in this particular one, I believe in this example, we're probably not going to have any PIM. So we'll let it finish up, and then we'll see what happens. So now it's completed, and you notice it says pass. So it says pass here. I'm looking at my bandwidth. I'm looking at the amount of PIM, and there's just obviously an incredibly clean signal. Probably not what you're going to get every time. If I go to analysis here, there's nothing to look at. If I go to CIPRI link, there's no alarms. So this is fairly generic here. So I'm going to go ahead and load a configuration that has some PIM in there, right? So you're going to see how it did a little LOS for a second there, and then quickly it showed auto-detecting. We also have the auto-detect button here. So if you press the auto-detect button, it'll go in there and detect your rates and the number of containers and those types of things. So I've gone ahead and done that. And so again, set my center frequency, and I have this one, I'll set it for 700. Actually, we'll do 680 just to have something different here. Apply this to all the containers. So all my different channels here or containers have that center frequency. I'll go and hit start, and then it'll go in and scan each one of those containers. So what I'm looking for here in the summary, normally I flag anything over about 3 dB. So over 3 dB, and so you see a couple here that are 8, 8.6. So, most likely some external PIM here. If we go to analysis, we'll see that on all the containers, we have interference. And so that's typically, if it's on all the containers, that's some sort of external PIM. And so you can select this here. And if you want to look at the spectrum in live mode, because remember, this is just a snapshot, right? It's a snapshot in time. I can go over here to the right where it says live view, and I'll go ahead and hit live view while I'm, have this analysis alarm selected. I'll hit live view, and it'll open up our optical RF analyzer in real-time mode. And so here's where you can start doing some of your advanced analysis, right? You can adjust the different channel bandwidths. You can get in there and turn on and off certain containers to look at them or select them, these types of things. And so right now you see the source. I can switch the source to a different source and look at it. So this allows you to do some of your advanced troubleshooting here, right? So this is where we started doing some of our advanced troubleshooting. And if I want to go back over to iORF, I would select this button here in the top right. You'll also notice that we have some different options here. So you can take snapshots, screenshots, those types of things, save the profile, even record. So if you wanted to record this to show it to somebody else, they can open it up, and look at the actual signal itself. And then, of course, you can do a report generation. We'll come back to that. But if I want to go back to iORF to do a new scan or to look at something different, I can go into here, say even summary, and I can select a particular, container and look at it here. I can go back to live view, and then it goes to that exact same one that I have selected, right? And so you kind of see, some of the power that we have there and the flexibility that we see. And of course, we go in here. Right now, we have no alarms as far as on the actual CPRI link itself. But for interference, we do have some issues here to address, right? We do have some issues. And in fact, let me load a different profile here to kind of show you. So I'm going to do something with some internal PIN. I'm going to open that up. And so if I go back to the setup here and re-auto detect, then I go ahead and start. And we'll set the center frequency at that the same was before. So now we're seeing interference on specific containers, right? And so you can look at these individually. So once it's complete, we see here on container number 1 here, we're seeing some high PIM here, right? We're seeing some high PIM. And in the analysis, this is going to be in the order of impact, right? So the worst interference is going to be on the top, and then we go down. So an internal PIM was detected on a container AXC1. I can select the individual peaks, and if I go to live view, and then we're zoomed into that exact same view in real-time mode, so for troubleshooting. And of course, once I have everything selected and I want to generate a report, it's very important to, I create a report, the initial report, and then I go out and, of course, during troubleshooting, during interference hunting, I would have this running and I'd be remotely logged in. And I'll show you how to remotely log into the unit here at the end. But I would be remotely logged into the unit and then doing some interference hunting, right? Getting out there, putting some blankets out there, adjusting, some settings, looking for and turning devices on and off around you as you can to see what happens, right? And so obviously I would want a report showing the interference, and then I would want one that just kind of shows everything, right? And so in this case here, if I want to generate this report, I go to here where it says generate report up top. I click on that. I will give this a name, job number, whatever information is required to put in here, and then I'll go ahead and generate. So this will generate a PDF report, and this PDF report will have all the information that you saw there. So we have the table of contents on the left so you can scroll around, but essentially what you see here is all of the information, right? The power levels, the different containers that were detected, and then of course kind of a quick summary of the PIM, for the different containers, right? And then of course the analysis diagnostics, and then the individual channels as well as captures of all of the different interference and spectrum within the different containers all the way through here. So this is a nice report to have. You can even generate a report within the live view as well. So in the live view, there's a report here. So if there's something you're doing with the markers or whatnot, you want to generate a report, you can generate a report within the live view as well. And And then, of course, at that point, once you're done, we can get back to our deck here. Once you have all of that connected, obviously you want to, normal everything back up, right? So at that point, after you've done all this testing here, right? We started iORF. We went ahead and, verified that we had link and that we had power. And then we set our center frequency. We selected the different containers that we wanted to test. And then we hit start. And then that runs through and does the actual test. And then once it's done and completed, we analyze the test data. So we basically analyzed all of the test data there. Let me move my head out of the way here. And so we analyzed the test data and then generated our report, did our troubleshooting and all that in between, toggled back and forth between live view and the actual snapshot. And then, like I said, basically just generated the report at the very end, and then you're done. Obviously, at the end of this, you want to verify all your power levels are sufficient and where they should be. And that, take another shot with iORF to make sure that you have a nice clean system. And then you can pack up and go home, normal everything back up, inspect and clean all the jumpers, and basically you're done for the day, right? And now that leaves us with how do you remotely connect to your device. So the FTB-1 is a full Windows 10 platform. So it is a full Windows 10 platform. So it does support, a lot of third-party applications. So if you have a third-party application, like let's say TeamViewer, you can use TeamViewer or something like that, right? Built within Windows 10, they have their own viewer. They have something called Quick Connect. So if somebody remotely wants to log into the device, they can. So maybe an RF engineer of some sort, right? So while you're running around turning devices on and off that's causing, say, external PIM, or putting blankets on there or tape or whatever you need to do to troubleshoot what the issue is, somebody can be remotely logged into the unit and analyzing as you go out and do your interference hunting in the field. To do that, so within the platform itself, so I'm going to go ahead and switch back over to the platform. Within the platform itself, we have an application. Well, Windows has an application, right? So Windows has an application within the platform that allows you to remotely connect. So it's kind of their version of TeamViewer. So TeamViewer is also an option. So you can get TeamViewer on the platform itself. It is a licensed application. So you have to make sure that that you have the appropriate licensing that you would need. But software like TeamViewer can be used. You can even install that on your phone and then be using TeamViewer on your phone to look at the platform itself, right? Within the actual test set itself, obviously you want to be online. So you want to get your test set on your Wi-Fi. And it's just going to be just like with any other PC. So down in the taskbar, we're going to have the option to connect to different devices, right? So if I minimize this here, minimize all of this, you'll notice the background is basically just Windows 10. So I'm going to go down to my Wi-Fi network here, and I'll go ahead and select my Wi-Fi and connect to it. So if it's a hotspot, then that's what you do. You connect to your hotspot. So that will give you connectivity to the internet. All right, so that'll give you connectivity to the internet. We can do Wi-Fi. You can do the LAN connection if you have a LAN connection at your location. In this case here, I'm hardwired in because it gets just less latency when I do a VNC. So I'm hardwired in, so I have a network connection. So what you want to do is down within Windows, you're going to have this search button. Go and hit that search button, and from here you will type in quick, just the word quick, right? And it should come up with quick assist, right? Quick assist. If for some reason the virtual keyboard doesn't want to pop up on you, what I like to do is I like to put the virtual keyboard on the taskbar down here. So if you right click on the taskbar, you can put the touch keyboard on the taskbar, right? But in this case here, since I'm VNC'd in, I don't need it. So I'm just going to type in the word quick. You see the word quick assist. So all you have to do is click quick assist, and this is on all Windows 10 platforms. So on the other side, on your PC, you would have somebody that would log in from the PC as well, right? So on my PC, I can go in here and type the word quick as well, and you'll see on my PC, I have the same application. So this application here at the top left is from my PC, and this one's from the platform itself. So if I want to assist another person, then I'll go ahead and click this, and it's going to give me a PIN number. So it's very similar again, like I said, to TeamViewer. So it's going to give me a PIN number, and this is the PIN number here. All right, so I would give this PIN number to the person in the field who's in front of the test set, and they will put in that code into this box right here. All right, and then once they do that, you hit share screen, and essentially it's going to share the screen with the other side. So I can do that real quick here just so you see it. Move this over to here. So I'm going to type into here 345980. So 345980. I'm going to share the screen. And then now it's going to communicate to the other side. So eventually I'll get something here on the other side that says connecting. I can either just view the screen, which is more bandwidth efficient, or I can actually control the entire thing. Now, of course, in this instance, if for interference hunting, I want to control the entire thing because the other person, the technician in the field is running around doing the legwork. And so I can hit connect here, and then it'll do its handshaking. You'll have to accept the permissions on the other side. As soon as you hit accept, and then you'll see we're connecting here on my PC. So again, this is on my PC here. So now we're seeing a bit of multiplicity here. So here's the actual test set. So I can actually, highlight things. You'll see in the background there how I'm highlighting things. And so this is using Quick Assist. And it's completely free and it comes with the platform, right? So this is a great application to use. I'm going to go ahead and shut that down. And so as you can see, that's a really great tool to use to be able to share it. That way somebody remotely can really kind of look at this screen here. And really that's kind of it in a nutshell, right? This is basically testing CPRI over fiber using EXFO's iORF application. My name is Kevin Peers with EXFO. Thank you very much for your time.